thought I would present some interesting findings on a tooth we did the other day. So initially, our attempt was to cut a tooth sagittally and see if what the effect of the gentle wave was on the interstitial tissue in between the two roots, trying to figure out if the gentle wave really can clean out that tissue. So we took a bicuspid, instrumented both canals, and then tried to section the tooth sagittally. So this is what the access looked like. The buccal canal was out to a 30.06, the lingual a 20.06, and then we cut the tooth sagittally to look at the isthmus tissue that we suspected was lying in between the buccal and lingual canals. So we look at it from the sagittal direction, and hopefully we get a fortuitous split by sectioning the tooth. And we'll look at about that level, and in that view, the sagittal view, and see what we can see. We'll also cut the apical end off at that point and look at an axial cut. We've done this before. Typically looking at axial cuts, we cut it axially and then examine that view under the electron microscope, and you get a pretty good idea of what the gentle wave is capable of, but you don't get a full view of the isthmus tissue. These are the axial views, and you can see, if you look carefully, the interconnecting tissue between the two canals has been relatively cleaned out. Even in the connector between the tooth, you can see that area has been fairly well cleaned of all organic debris, and you just have kind of the typical gentle wave appearance of partially decalcified dentin in that area. When you look at conventional instrumentation or endoactivator type instrumentation, it doesn't even touch this tissue. The tissue is always remaining. So this is a similar tooth to what we actually did, and we're going to section it both apically and sagittally and see if we get a good split. As I mentioned, the canals are to a 30.06 and a 20.06 on the lingual. So there should be plenty of tissue in between those two roots when we split the tooth. So we cut the apical end off axially, and then at that level, we'll look at it from a sagittal perspective. These are the diamond discs we use. There's the apical part of the tooth being sectioned off, and then we take the tooth and we split it longitudinally on both sides and then crack it open and hope that we get a fortuitous split that will enable us to view, in sagittal view, all of the webbing in between the two canals. On this particular tooth, there was just one canal, but you can see that's a fairly good split, and you can see both halves of the tooth and all of the tissue in between. So this is actually the tooth that we did, and there you can see the two canals, and that area in the middle between them is what the isthmus tissue looks like. That is where the isthmus tissue was. And you can see it has the gentle wave appearance of partially decalcified dentin. I can detect no tissue remnants whatsoever in that space. So I'm going to give you this in several views just in case you're having trouble with the orientation. That's an example in the picture of probably where I suspect that we are. And then looking at the actual tooth, that's the area where we're looking at, the area in between the two canals. And here you can see the complete removal of all evident tissue in that isthmus area. And you can see it's just partially decalcified dentin. Here you're at the border between the instrumented canal and the isthmus tissue, and you can see that the dentin looks different. If it's been instrumented, it looks completely different from uninstrumented teeth or areas. So the isthmus area is untouched by any instrument, and you can see that the decalcification is kind of a partial decalcification. There you get a better sense of what that partial decalcification looks like. It's almost as though the instrumentation either removes that less calcified dentin and makes it easier for the genital wave device to remove it, or it compresses it into one layer. But where there is no instrument, there's a very uneven decalcification of the dentin, and there's must be a gradient, a calcification gradient as well. So the more superficial dentin is probably less calcified, hypocalcified, compared to the underlying dentin. Here you can see the two instruments, and here again, there's an area of the canal that's been touched by an instrument, and there's also an area of the canal that has not been touched by the instrument. And the look of that dentin is completely different. And this can help, understanding this can help in evaluating what's actually been done. Here you can see the margin of where the canal was instrumented and where the canal was untouched. So the dentin has the typical genital wave appearance of removal of the substrate, whereas where it has not been touched looks very clean, but it obviously has not been touched by an instrument. And that's understandable given the very small sizes that we used on this case. When you actually go into where the actual margin is between the instrumented and uninstrumented part, there you get a very good sense of how different the dentin actually looks. And here you can see kind of the partial decalcification of dentin. So you have the higher calcified dentin underneath this layer, and this layer, the more superficial layer, has not been completely decalcified in areas that have not been instrumented. And if you go in tighter on this, you can actually see indications of the collagen fibers in the dentin and how intertwined they are. So there again, you can see the difference in the appearance of instrumented, uninstrumented, and isthmus dentin. They all look differently. This is instrumented dentin, and you can see how much smoother it is and how much more uniform the decalcification is. It goes right down to the harder dentin. Again, no indication whatsoever of any organic debris whatsoever along the canal wall, whether it's been instrumented or not instrumented. It's just that the dentin looks different. This is actually in the instrumented part of the root, how the dentin looks. Now we're going to look at the apical segment of the root into axial cross-section. And here you can see this is down near the apex of the root. And when you actually zoom in on it, we got a very fortuitous sectioning here because you can see some of the interconnectors that are present, some of the vascularity that is present in between the buccal and lingual canal. And when you actually zoom in on this, we're able to actually examine that. And again, no actual organic tissue was detected. Even those interconnectors look relatively clean. So that was kind of surprising to me. As you go in at higher mag, there's really no tissue remnants left in those interconnectors. If you were to look at an endoactivator, that would be just filled with tissue. So I hope you enjoyed this. That's basically where we were looking.